Bon après-midi, bonjour. Je vais parler en anglais parce que tout le séminaire est en anglais. Mais, je m'excuse pour cela. So, I'm Simon Hodson, Executive Director of CoData. CoData has been introduced a little bit already by Bill and in the introduction in that timeline. I'll say a little bit about CoData, but before I lead into that, I really want to highlight some of, I found that a fascinating presentation from Bill, and in particular, I really enjoyed the emphasis upon some of that history and the investments on international research programs, which produced excellent science, but for which the data legacy is really, really thin. And I find that an absolute tragedy. And I'll give a specific example in the presentation of something similar with considerable humanitarian implications as well. But I want to mention a couple of other examples along the lines of what Bill mentioned. In the late 2000s, there was the International Polar Year. I think it was 2007, if I remember correctly. There's a series of articles by Mark Parsons, who for 3 years was the Secretary General of the Research Data Alliance, which has already been mentioned. Mark wrote a series of articles looking at the data legacy of the International Polar Year of 2007, and it is minimal. The data has been spread to the four winds. I was involved in a report for an organization called Knowledge Exchange, which was intended, the report was intended as a response to the European Commission's Riding the Wave report. And we call that a surfboard for riding the wave. And in that, we used an example from Denmark of 3 circumnavigating research vessels. 3 research vessels that circumnavigated the globe, collecting data, conducting science, one from the 19th century, one from the 20th century, and one from the early 21st century. Guess which produced the greatest data legacy? The 19th century, the first one. Partly because it's written on paper, and paper is very easy to preserve through benign neglect. The data from the 21st century research voyage, there was no central catalogue. It had gone to the particular research groups that had booked time and activity on the vessel. Science had been done, but we had no idea where the data was. And this is a tragedy. This is really something that is preventing the forward march of science, and it needs to be addressed. And it needs to be addressed in many ways by the things that Bill has mentioned. I'll say a little bit about CoData. We've gone through, as any organization that's existed for a while, through various evolutions. We're a body established by the International Council of Science. So we serve that organization's mission of promoting science globally for the benefit of society. But we do so by addressing issues relating to data, so the availability, the usability, and the quality of data. We do so through 3 strategic priorities. We work in the area of data policies, and we do reports and studies along those lines. 2 of the most recent and significant ones is Open Data in a Big Data World, which was conducted for our parent body and work for the OECD, etc. The second area of priority, or the strategic priority, is what we call frontiers of data science, and that's looking at technical issues around the understanding, the communication, the annotation of data. We have a data journal or a data science journal, and we run a regular conference, of which more later. And we do a lot of work in capacity building as well, training courses in data science. And there's a regular course which we run in partnership with the International Centre of Theoretical Physics, based in Trieste. And this year, really thanks to the success of that course, we're going to be running courses in Brisbane in June, in Trieste for 3 weeks, followed by a 2-week foundational course and a week of advanced workshops at ICTP in Trieste, in Kigali in Rwanda at an ICTP campus there, and for the second year in Sao Paulo in Brazil. I do hope we'll be able to fix these slides because it's a pain them being cut off. But, should I see whether I can address because it'll be a resolution here, or do you think it's a resolution in the screen?
I think it's there.
I don't really want to interfere with this system though. I'll soldier on. We can't see the so.
If they're not animated, you could come out of slide view. Well, no, she's recording.
She's recording, so that's what I don't really want to change. This slide is intended to address the question, which you can't see at the top because the title's cut off, of why open science. So Bill's addressed some of these issues, but I wanted to mention quickly 3 strong arguments for the open availability of data. The data should be fair, and the sort of open science approaches that Bill was talking about with that wonderful example of how time was being saved by doing advanced work with data science, by annotating the data, and really essentially saving time, making the research more efficient. So first, good scientific practice depends upon communicating the evidence. What we do as researchers, what we do as scientists, is present our findings based upon evidence. That's the fundamental distinction. And the evidence is the data. And if we cannot access the evidence, if we cannot access the protocols, the software that has been involved in creating or analyzing the data, then we cannot communicate effectively our science, and those findings can't be reproduced, they're not replicable. To some extent, data was always communicated. But when data could be communicated effectively in a little table in a printed journal, that was one thing. But when the data is based upon many databases, upon a corpus analysis, upon a algorithm sent around a huge data stock, then it's very difficult to communicate that effectively. But at the very least, as we heard from Bill, we need these journal data policies that require, as a condition of publication, that the data that underpins the findings in a given research article should also be communicated. The president of CoData, Geoffrey Bolton, at the Royal Society, was the lead author of the paper or the report that you see at the top right there, Science as an Open Enterprise. And one of the arguments of that report was precisely this, that the data should be simultaneously communicated along with the research findings, and that a failure to do so is tantamount to scientific malpractice. Secondly, I wanted to mention one of the other great arguments or important arguments for open science and the approaches that Bill has already discussed, which is that certain areas of research, and some with which you'll be very familiar, have been transformed, revolutionized by the open availability of certain data types. The poster child for this is often genomics and the ready availability of sequence data and the ability to search across those sequence data at scale. But other examples can be drawn from astronomy, certain areas of astronomy at least, for those areas of research which use openly available remote sensing data, etc., etc. And this is why it is these transformations and the observation of these transformations which have led to those policy changes that Bill has already alluded to. And in particular, this coalescence around this idea of fair data. And then finally, there's this hope, which can be attested in some instances, that open available data will lead to open innovation, greater societal engagement with science through citizen science or through transdisciplinary research. Examples of that sort of engagement with science and the benefits of what's sometimes called the data revolution for sustainable development and for human progress more broadly can be found in this report from the United Nations, the World That Counts, which you may be familiar with, which looks at the sort of data which is currently being gathered, the sort of data which is potentially available, such that we can both monitor and advance the societal development, the sustainable development goals, rather. And it makes a case for the increased use of open science, of data science, and openly available data to address social sustainable development issues, and provides a menu of what's needed to better understand what is required for sustainable development and how we address those goals. Give an example also of the sort of data harvesting, this is just one example, and by presenting this, I'm not necessarily endorsing the findings or the activities of this particular project, but it just shows that what can be done through openly available data, through analysis, through data science. It's GDELT, and without the title, so it's Global Data Set of Events, Location, and Tone. So it's supported using, Google is involved with this. It's a sort of an international research group that harvests information from printed media, from online media, from certain social media as well, about events. They geolocate it, they timestamp it, and they use various controlled vocabularies and algorithms to identify the tone or the nature of those particular utterances and the relationship to particular events. So it's one of these examples of application at scale of data science. And they have nice visualizations where you see responses to particular news activities going around the globe. It shows what can be done through open available data, through intelligent algorithms, through machine learning, and through effective classification schemes. I wanted to mention and apply that to a consideration of how we address, this is just one example, waterborne infectious diseases. If we want, think about the global programs that I mentioned for the polar year, these grand research programs. For research into waterborne infectious diseases, the sort of data sets that we would wish to gather if we were to analyze in the round, in a holistic way, the nature, the propagation of such diseases. Data relating to the agent biology, the population genetics, the water supply, the sanitary engineering, travel and transport, population movements, etc., social habits, climates, etc., etc., etc. Now, in principle, we can, in principle, to address the sort of questions that we would want to ask about the propagation of waterborne infectious diseases, these are the sort of data sets that we would want to gather. And the science is often hampered, inhibited, either by our ability to access these data sets, or, importantly, by our ability to integrate those data sets with others, to incorporate them effectively into models or visualizations or systems of analysis. And so what I want to talk about a lot in this presentation is an initiative that CoData is leading to, as part of the International Council of Science, our parent body, to try and address these sort of issues in a number of specific pilot projects. So I'm going to give one of the examples of the pilots that, that we're engaged with, which relates to infectious diseases. This is a slide from Laura Merson from the Infectious Disease Data Observatory at the University of Oxford. And it is intended to show the great international effort which went into responding to the Ebola outbreak in West Africa a couple of years ago. A considerable amount of resource was mobilized, a considerable amount of intervention from governments, from third sectors, from charities, etc. And a lot of data was gathered. The genome was sequenced. Data was gathered also on the ground by those organizations. And those data are essential for us to understand the propagation of the outbreak and which interventions were effective or not. And the study that's been conducted by the Infectious Disease Data Observatory finds that very little of those data, very few of those data are currently accessible. They've gone back to the particular agencies or researchers that were involved. They've gone back to the charities, and they're scattered to the four winds, and they're very little available, they're very little accessible. And that's something that if we want to understand how that outbreak, as I say, developed, propagated, and what the implications were of particular interventions, we need to be able to reconstruct those data from those various agencies and activities. And very little, as I say, very little of it is available. I'll go into more detail about the initiative that we're developing later in the talk. But I wanted, as part of that, just to introduce this slide, which comes from some of the preliminary work that we've been doing with Laura and her group on the sort of data that you would want to gather to understand the Ebola outbreak. So, and this builds upon that example. I mean, from a different example of waterborne disease. Where do we want to go for these data sets? We want to gather them from industry, from the research community, from national public health surveillance, from climate and environmental monitoring systems, from health systems, etc., etc. They relate to, or the data relates to, or is clinical data, genomic data, demographic data, pathogen and vector surveillance, communications, land use, health administration, environmental data. These are the sort of the things that the data relates to, or the data types. And then the data formats. And here we're sort of drilling down into how we would use those data, what format they're in, how we would incorporate those into a model or into a particular database. Well, they're in spreadsheets, they're in CSV, they're in plain text, they're geospatial in some instances, they're in varieties of XML and JSON, or they're in relational databases. So this tries to communicate the challenges that we face in bringing those data together, in accessing them, and then in using them scientifically. So I'll step back for a moment and mention something and talk a little bit about something that Bill mentioned, the FAIR data principles, which are these guidelines and really on how data can be effectively managed and how we can add value, how we can increase the value of data for future reuse. So there's a set of principles that I hope, I'll ask, before Bill mentioned them, who is already familiar with the FAIR data principles? Is this something that's, so quite a lot, there's been a certain amount of communication about this. So I'm not going to go into these in great detail, but this idea that in order to have value, data should be findable, you should be able to locate it. There should be some protocol whereby you can access it that they should be interoperable, and there are specific meanings for that, both technically interoperable and semantically interoperable, meaning that we have a shared understanding of what it is, a shared definition of what it is that has been measured, what the value is that we're looking at in the database, and that they should be reusable. So there's sufficient description and provenance information for us to be able to assess the quality of the data and the usability of data, and to be able to use them effectively. Now, these didn't come out of nowhere. As we saw from Bill's timeline, in the data science and data management communities, we've been talking about these attributes for some time. And there have been previous attempts to list the attributes that are necessary for data to be as reusable as possible. Unfortunately, none of those attempts came up with as catchy and as easily communicable an acronym as FAIR. But I just give those as some examples. One of the ones that's often neglected and possibly should be incorporated within FAIR is accessible. One of the things we want to do when we look at a database or a data collection is to understand how effectively the data was gathered, how it was gathered, and to determine whether or not it's usable for our purposes. And as a result, there have been some efforts to add additional values to data. One of the things we always insist upon, and I should mention in talking about this, that I chair the European Commission's expert group on fair data, and will be publishing a report and guidelines on fair data implementation by European Commission projects at the end of, or at least in draft form for consultation at the end of May. One of the things we often insist upon is that data should be as open as possible, as closed as necessary. This is a necessary supporting concept for the FAIR principles. But others have talked about FAIR TLC, that we need to trace the origin of data, that it needs to be licensed and connected, that it should be rapidly available. And so I use this really to show that FAIR is a very useful guide, but it's a necessary but not quite sufficient guide for effective data management and to ensure that data is effectively reusable. Things that we need to think about as well are, of course, the timely release of data and its long-term preservation, things like the responsibility of users as well. And in particular, the two most challenging areas of FAIR are the issues around interoperability and reusability. And it's the challenges around this that really drive the CoData initiative for data interoperability and data integration. We can take some guidance from the OAIS model, which is the Open Archives Information Systems model, and this principle that data that we collect, that's then deposited or made available as part of our scientific research, should be independently understandable. And this is the work that was going on in that group that Bill mentioned. How do you make sure that the data is not just understandable by yourself, not just understandable by your future self in a year's time when you've forgotten exactly what those annotations were, but how is it independently understandable by third parties? And we have also this concept of designated community, the people who might use those data. But we face a very considerable challenge in making data usable beyond the designated community for groups that we might not be immediately working with, for groups that might want to use the data for a purpose and objective and sort of research that we haven't currently conceived. And I don't propose to go into that in a great deal, but I think it's a very important challenge. Now I want to move back, having discussed FAIR and those ideas of the data should be independently understandable, move back to this, to the CoData initiative on data, on making data interoperable and integratable for interdisciplinary research. A lot of the major global challenges that we face at the moment rely in particular upon what we might call interdisciplinary research. In research which looks at the global system, for example, and then looks at the interaction of human society with that global system, whether that's in ecology, in the growth of cities, in disaster risk research, etc. And that requires collaboration across domains, and it requires the integration and the interoperability of data from a variety of sources, as I've already mentioned with some of the examples. There are examples in programs which are sponsored by the International Council of Science, which is as I mentioned, our parent body. So the Future Earth program you may be aware of, or integrated research on disaster risk, or programs looking at health and sustainable cities. And also a background to this initiative is the fact that the International Council of Science, our parent body, will be fusing in July in the General Assembly held here in Paris with the International Social Science Council. So that new body, the International Science Council, has a particular mandate for interdisciplinary research which incorporates the natural and the social sciences. We've been doing work in data science and in the development of standards across domains for a number of years. This is just one example on work we do on the description of nanomaterials. Before I got involved with this, I didn't think that nanomaterials was an interdisciplinary research area, but food scientists, biologists, health scientists, nutritionists, etc., ceramicists all look at nanomaterials and all look at them from very different perspectives and have different vocabularies, different concepts which are used to describe the properties of those nanomaterials. And this was an attempt to bring together researchers from different domains, represented in different international scientific unions, to look at the different controlled vocabularies on ontologies that they were using and to try and combine them into a uniform description system. That's shown some success, and it's been adopted and trialed in a European Commission-funded project. And so we wanted to do something similar with these international interdisciplinary research areas which tackle major societal problems. So this is the CoData initiative for data standards for science. We've held a series of workshops, one in June last year, pendant la canicule, ainsi les glaces. It was, as you'll know if you live in Paris, it was nearly 40 degrees at some points, and we don't have air conditioning in the ICSU offices. But there the objective was to bring together, on the one hand, researchers from different domains, representing different international scientific unions or different areas of research, and the standard bodies which develop metadata standards, vocabularies and ontologies for particular areas of research, and to understand and to start developing case studies for the application of activities to address interoperability to particular research areas. We held a follow-up meeting at the Royal Society in November, at which we identified these first 3 pilots, and we're discussing whether or not we can add agricultural research to this initiative. But for the time being, we're working with 3 pilots on interdisciplinary research areas in infectious disease, hence the Ebola example that I mentioned, in disaster risk research, and in resilient cities, and in particular because they relate to activities of the International Council of Science. The way the activity is working is that, on the one hand, we're working with those pilots to understand particular research questions, to understand the data availability and data quality issues, and then to do an analysis of the challenges in terms of data interoperability and integration. And that's supported by a data science activity, which is drilling down with those pilots into those challenges, and attempting to draw broader lessons from those findings. So I've already mentioned that one of the groups that we're working with is Ebola, the infectious disease outbreaks, and this is the sort of approach that we're taking. We're trying to look at these various data types and to see what the challenges are for their availability and their use and their interoperability when it gets down to integrating the data in models or other scientific analysis. So the title there should be Initiative for Data Integration, Pilots and Case Studies. So we've got funding for this pilot stage to work closely with these three areas. And these are the sort of questions we're asking. We're developing this set of questions at the moment, and it so happens that Bill is involved with this, and he's been leading off on this discussion. But I thought this might be interesting to communicate the sort of questions that we're asking of these research areas. So what is the overall question, the research question, the societal question of significance for society and humanity that you're trying to address? What are the additional research questions that you're tackling? And then moving on to these data science questions. What are the data sets which you need to be accessed and assembled? So think of those examples from the Ebola example. Who owns the data? How is it licensed? Can you get access to it? Are there restrictions on the use of those data for privacy or whatever reasons? Where are they stored? What are the access requirements? What's the data format? What metadata, if any, is being used? What's the provenance information? What are the semantics? What vocabularies or ontologies are defining the concepts being used and the attributes which have been measured, etc., etc. Now, this is something that we do as researchers when we gather data, when we compare this. To some extent, we have to make these assessments. But it's very rarely articulated. It's very rarely communicated. I was involved in a project funded by IRDC, the Canadian development funder, where we did a similar sort of approach. We did a data audit with a set of their projects. And it's something that's really not part of the general culture of science to do this, to articulate these things very specifically, which in many respects I find surprising, given that this is the core, the data is really the core of our activity. So we hope by doing these studies, we'll be able to then move on to the second stage of developing, assisting those projects in, we'll describe the data stewardship situation, we'll do a gap analysis between the data being gathered and making those data fair, that will identify existing standards, etc., or, having conducted that gap analysis, indicate where extensions are necessary. And we hope that through that, the projects will be able to demonstrate some quick wins, to conduct some research that they otherwise wouldn't have been able to do because it was impossible to bring those data sets together. And of course, one of the things we want to do in a long-term program is draw broader lessons for interdisciplinary research projects. Got a couple of 2 or 3 slides to wrap up on this. You might be familiar with this cartoon from XKCD. If you're a data and a standards person, this is both true and slightly irritating. So it communicates a core truth, that there's always this idea, and very much as we did with the nanomaterials project, which I mentioned earlier, to say there are all these different standards, there are all these different definitions, let's bring them together, and what do we have? We have yet another standard. And yet, it somehow drastically misses the point, in that standards are necessarily evolving, they accrete, they need constant work and updating. They're not a fixed thing. And in a data-intensive world, in a world that relies more and more on the availability of data, definitions contained in vocabularies and ontologies, data standards which help us describe particular values, the way in which data was collected, that give that provenance information, they are fundamental to our practice. And in some ways, we have no other choice than to keep working on them, to keep improving them, to keep extending them. And we also need to recognize that there are a proliferation of standards. There are many standards which some people just like to write standards. It's an attitudinal thing. But we need a way of determining the effectiveness and the applicability of particular standards. One way is to have a star system which determines whether something is just a list of words that someone's come up with. I'm sure you'll be aware in your field of all the minimal information standards that exist in the life sciences, some of which are used and some of which are not used. And also we can hope that initiatives like Faire sharing, which used to be bio-sharing, can help us with that task. I've long thought that Faire sharing, I don't know whether people in this room use this as a resource to identify standards. It's a database that lists standards and minimal information and reporting protocols in the life sciences and now beyond. It lists those standards. It provides additional information about them and some degree of appraisal. It also indicates whether they're recommended by any data policies. And above all, it lists whether they're implemented in any database or whether they're a standard that's been written and has scarcely seen the light of day. And through such initiatives, we can hope that there'll be an evolution in the way in which standards are developed and implemented and improved. I'm going to skip over this a little bit, but this is really just about the expert group that I chair and what we're doing as part of that activity for the European Commission. And we'll be publishing the draft report for consultation on how to make fair data a reality with an action plan for European research projects and the European research area in early June. And of course, in achieving these things, in achieving the sort of things that Bill mentioned, standards are important, vocabulary is important, the sort of things that I mentioned as part of the CoData initiative, but we also need to address things more holistically and consider the life cycle of data, which Bill has already indicated, and how we support that through training, through infrastructure, through the availability of resources in research institutions to look after our data when we create it, to look after the live data, and the responsibility of most research institutions, if not all, to provide data resources, data repositories for the researchers in those research institutions. There's some indications there, and this is a research data management lifecycle diagram which the Digital Curation Centre in Scotland used, which was developed in a program I managed in the UK a few years ago. And I'll close with a plug for our conference organised with the World Data System, the Research Data Alliance, as well as the University of Botswana and the African Open Science Platform. International Data Week, it's a combined conference of CoData and the Research Data Alliance, and it's taking place in Gaborone in Botswana in November this year. And hopefully it'll be of interest. There's lots of stuff about data of agricultural, ecological, and biodiversity data in the conference, and hopefully that'll be of interest.
Okay.
Thank you very much.